Hello and welcome to my final physics lab, Lab 5, Gravity and Horizontal Velocity. So the purpose of today's lab is to confirm the universal acceleration of gravity, specifically the effect of gravity on an object in various kinematic conditions. So the models and principles I'll be looking at today are universal gravitation and the momentum principle, or Newton's second law. So previewing my result, I found that when a horizontally thrown and dropped object are released, they would impact the ground at the same time. So the models I took a look at to go further into it are, to start with gravitation. Gravitational force is proportional to both masses and inversely proportional to the square of the distance, and most importantly can be approximated to be the product of mass and acceleration of an object due to gravity near Earth's surface, which is about 9.81 meters per second squared. So the momentum principle states that the net force applied to a system is expressed as a change of momentum, with the net force being directly equivalent to that change of momentum. So for my experiment, I defined the system to be the two hockey pucks which are thrown in the video, which I'm about to show, and the surroundings to be the Earth and all other physical objects, which are applying gravitational forces to the pucks. So the initial conditions are that two hockey pucks are ejected from a person's shoulder height, with one being thrown outwards and the other being dropped directly downwards. So for this experiment, I performed a experiment which is only physical. So I threw two hockey pucks. I tracked the motion of these hockey pucks using tracker, and I determined the time of impact for both. And then I analyzed the time of impact to determine how similar they were. So I used this video for my tracker data. And then here are my results. So my calculations for this lab found that the impact time for the object which is thrown horizontally was 1.803 seconds from first motion. The impact time for the dropped object was about 1.635 seconds from first motion. The delta t was 0.168 seconds. The difference of time is about 10.27% of the time of the dropped object took to hit the ground, so the differences are likely insignificant. So to analyze this result, the behavior of both objects suggests that it takes a very similar amount of time for both objects to fall to the ground, regardless of whether they're projected outwards or dropped. This aligns precisely with the universal law of gravitation, which states that the acceleration of an object due to gravity can be approximated as constant for small objects near the Earth's surface. This means that the vertical momentum of each object will change the same under the effect of gravity, causing them to reach the ground at the same time. There are numerous sources of potential error for this experiment. The first was that the tracker data, if you noticed, suggested that the thrown object was not thrown perfectly sideways. In fact, it climbed slightly. This would explain a lot of why it took more time to hit the ground, as it needed to travel further up into the air. There is also the effects of camera parallax, where as the camera is not viewing the motion from side on, it is difficult to accurately and precisely determine where it was vertically. And finally, the effects of air resistance could have produced a small effect if the one puck was aligned to produce more drag and one puck aligned to produce less. So how is the acceleration of the objects constant? When one considers the equation for universal gravitation, they will see that the force of gravity is dependent of the masses of both involved objects and the distance between those two objects. For an object that is near the surface of the Earth, that can be approximated as a radius of the Earth and the mass of the Earth for two of those values. This only remains the mass of the object that you're considering on that side of the equation. This can be divided out from the force expression to state that which ultimately reveals that the gravitational acceleration of Earth should be constant for an object near the Earth. So if the thrown object is not projected directly outwards, you can consider that situation using standard kinematic equations. With identical accelerations, an object which must reach the ground from a different height will take a different amount of time to do so, which is demonstrated in this experiment. That'll be all. Thank you very much, and good luck on the finals.